Okay, we're going to do areas of regular polygons, and then we'll summarize everything we've done. And we are going to find the formula for a regular polygon and apply formula areas to solve problems. The formulas are not a problem. Okay, you guys. Now, I'm going to start with a regular polygon on this slide. Everything is on the next slides, but I'm going to start with a hexagon. And we have to remember what regular means. Okay, guys, let's get started. Okay, equilateral, which means all the sides are equal. Okay, Phoebe? Focus. I want to say I won't talk long. This lesson's not that long, but you have many questions on the homework because there's some hard problems there. Okay, Zach, Garrett? And it's also equiangular. And I'd like to find the area of a regular hexagon in this case. Well, I don't have to memorize the formula. I just have to think I'm in the center there. Which right? That's not the center? I want it to be in the center. And if I take this, it's called a radius, and I draw out all the vertices, what do you think is true about my triangles? They're all congruent. Okay, my picture's not great, but it's okay. Better than the last one. There. So all the triangles are congruent. So what is the formula for the area of one triangle here? Of any triangle? Lane, do you know? What's the area for a triangle? And we haven't decided yet whether or not we'll give you formulas. The reason we would not give you formulas would be because you are not giving those on the ACT. So you have to know the area of a triangle on the ACT. It's 1/2 what? Base times height. And what I would recommend you do on the test is, and when we finish today, I'll summarize all the formulas, is the minute I get a test, I would write all the formulas down in front of me. Then that takes away the stress of saying, oh, what was the formula for height? You've written them down. Okay, so I have area equals 1/2 base times height. Well, this is the base, and then I'm going to draw the height. And the height goes from the vertex down to the midpoint, and it's also perpendicular. It's actually a perpendicular bisector. That's the height, and that's the base. Well, we're going to give the height a special name, and the height's going to be called the apothem. We're going to call it A. But it could call it apothem, too. I'm not sure. We haven't decided which. Okay? And that's just a special name for the segment that joins the center of your polygon, and it's perpendicular to the side. It's also a midpoint. So it's perpendicular to the opposite side. And we don't know enough about triangles yet, but we know we get a whole bunch of congruent triangles. You know, just by looking at them, you can see that they're the same. Yeah. Okay, so I want to find the area of one of these triangles using my new letter, and instead of calling the side the base, I'm going to call it S for the side. But it doesn't really matter. So what's the area for that yellow triangle if I use my new letters? So this is for one triangle. It's 1/2. Instead of the base, we're going to call it the side because all the sides are what? Equal. And the height, instead of calling it the height, we're going to call it the apothem, which is A. Now, what's true about all my triangles in my hexagon? They're all the same. So, well, an apothem is a perpendicular bisector of this side, and I know that for a fact. Not necessarily just the height. This is special. It's in a regular polygon only, not in a regular in an ordinary triangle. So the hexagon is 1/2 times the side times the apothem times 6. I'm just going to do a little rearranging here. I'm going to switch the A and the S because I can, and it's 1/2. and it's the apothem, and it's S times 6. What is S times 6? It's, yeah, we have 6 of these. What's another name for that as we go around our hexagon? Starts with a P. Perimeter. If you take 6 times the length of the side, you have the perimeter. So there it is. There's the formula. It's 1/2 A times the perimeter. That's the area for a regular polygon. I don't care what it is. Now the perimeter is equal to the length of the side times the number of sides. And that's the length. So I have another formula, and it all depends on the question as to which formula I want. So area is equal to 1/2 A, and then it's S times N, because that's the perimeter. It's the same thing. If I rewrite it this way, it's 1/2. This is just a little trick I could do. A and S, and I use A and S to stand for answer. So if that's a way to help you remember it, what the letters are, then use that. And that's all there is to regular polygons. Well, that's all there is for right now. We get right triangles, but we don't know about right triangles yet.
We're going to not do right triangles this
Oh, we're going to do right triangles, not this unit.
Oh.
Okay. So that's right here. On the next slide, what's a regular polygon? It's equilateral. Might as well fill it in. And it's equiangular. And we talked a lot on apothem. It's perpendicular segment from the center of the polygon to one of the sides. Not only that, it bisects the sides, so that is a midpoint. Might as well know it now. And there are the formulas. 1/2 AP or 1/2 ASN or ANS, doesn't matter. So this assignment is a little bit easier than last night. Last night was a little tricky. And then I have a mistake on mine, so I have to fix it, and I'll put it back up. I don't know. I don't think so. I didn't notice. Well, you're going to ask me questions on homework. Okay, ready to try some problems? Now, a lot of you don't want to write the formula down. I need to see something. I need to see the numbers you substitute in at least. But if you go through and read my answer keys, you should be able to figure out how to do the problem if you couldn't figure it out before you looked at them. I want the area of this pentagon, so n equals 5, and I can either use area equals 1/2 A times the perimeter, or I can use 1/2 A times the number of sides times the length of the side. It's the same thing, because this is the perimeter. Well, guess what? I have the apothem. What's the apothem? 12.45. How many sides are there? 5. And the length of each side is? 12. Right. And I could do the rest of the work if you want me to. I would do half of the 60. That's 60 right here. Or I could do half of 12. So it's going to be 30 times 12.45. So it's going to be bigger than 360. I don't know how big it is. Do we care?
It is 373.5.
373.5 centimeters squared. So it's not terribly difficult. It's easier than the trapezoid stuff, except it's a new formula. Now this, what does this look like? They didn't really tell us that, but it is. This is a square. So let's do this problem 2 ways. Let's use the new way, because a square is a regular polygon. So I should have told us it was regular. But the area equals 1/2 A times the perimeter. So what's the apothem here? 5. The perimeter is the number of sides. How many sides are there? 4. Be careful. What's the length of the side?
10.
It's 10. See, now it's clear. When you look at this, it's clear what my numbers are. At least then you can ask me, well, where'd you get the 10? But when you just have an answer only, I don't know. And I don't know how you got the answer. So it's 1/2 of 5 times 40. Half of 40 is what? Half of 40 is what? 20. 20 times 5 is 100 square centimeters. Now, would I use that formula for a square? Oh, probably not. Because what's the formula for a square? It's base times height. Let's do it the other way, because no matter how I do this, the area always is the same. So the base is not 5, but it's 10. And this side is also 10. And the answer then is 100 square centimeters. I would prefer in a square to use base times height if I have that information. Later on, we'll give you this hypotenuse, and we'll have to figure out all those other pieces, but not yet. Is that okay? That's pretty easy. Now, I can draw the picture. For some of you who are visual learners, you would prefer to see the picture of my pentagon, so I'm going to draw it. And it says A is 6 centimeters, so that's this, 6. The side is 8.4. And I want to find the area. It says it's a regular pentagon. Now we could really change it up and say the sum of the interior angles is something, and then you have to find out what side kind of figure it is. So we can get these to be multi-layered problems. But this one's not too bad. Does the picture help for some of you? The formula is 1/2 A times the perimeter. Well, A is 6. And the perimeter is, there are 5 sides, right? And how long is each side? 8.4. Well, half of 6 is 3, times 5 times 8.4. I don't know what that is. 15 times 8.4. Who's got their calculator?
Me.
It's what?
126 centimeters squared.
I'm sorry, I couldn't hear you though.
126.
126 evenly?
Yeah.
Centimeters squared. See what I'm talking about by writing the formula down? I know when you have to add up a whole lot of pieces in one particular figure, then that gets to be cumbersome. But if it's just one figure, and it's going to tell me what to do most of the time, if I don't know what to do. Okay, what have we got here? Find the length of one side of a regular nonagon. Amazingly, I can do a nonagon. Yes. Okay. 9. That's how I remember that. Hex, 6. And the other ones are pretty familiar. 7 I remember because of the French. Okay. So I'm going to draw in my apothem, which is 3.2. 3.2 centimeters. The area is 100.8. Find the side. Okay, I've got two formulas. I've got 1/2 AP, or I've got 1/2 the apothem times the number of sides times the length of the side. I want to find the length of a side. I want this, so I want the second formula. I can do it with the first. Eventually you'll figure it out, but it's just easier if I do this. So what goes in for A? No, what's A? 100.8 equals 1/2. I'm sorry, wrong A, my mistake. The apothem is 3.2. How many sides are there? 9 times the side. Is it easy to miss one of those little factors? Yes, it actually is. Okay, ask. There's the 1/2. There's the apothem, which is right here. And a nonagon has 9 sides times the length of one side. This is the perimeter.
What is 100?
That's the area. They gave it to me. They have to give you something. So when you don't know what to do, if you write down the formula, put the numbers in, I think you'll figure out what to do. I can't do anything with the left, but I can take half of 3.2. What's half of 32? 16, the decimal stays there, times 9s. What's 16 times 9? Well, let's see. 9 times 6 is 54. 5 and 9 is 14. You count back 1 because there's one decimal place. You remember how to do that? And then we'll divide by 14.4. So then I do a little reteaching of arithmetic here. I can't divide by a decimal. I don't know how to do it. So what I'm going to do is multiply the numerator by 10 and the denominator by 10. What is that equal to? I'm previewing a little bit of things we have to do in calculus even. That's 1. I don't change anything. But multiplying by 10, move that decimal over one place. So it's 1008. Multiplying by 10 will make that 144. And I don't know how big that is. Is it exactly 7? Well, that's nice. 7 what? What are my units here? Centimeters. So by writing down the formula, I made the problem easier. And so some of you have some problems with that because you don't want to write it down. So when I come around, I'm going to say, how did you get those answers? So you're going to ask me a lot of questions on homework. And last but not least, the area of the shaded region. And I made this way harder than I should have in the first class. Well, that's the problem solving. It's the geometry here. I'm going to, what shape is this? It's a what? How many sides are there? There's 5. I want just the shaded region. How many triangles do I have? There's 2 ways to do this. There's 4 triangles, right? 4 green triangles. Can I find the area for one of them? And they're all the same. And then multiply by 4? Okay, let's see what I have. I have the apothem is 5 centimeters. That's 5. This is also 5.
They're all 5.
They're all 5. And the length of one side is 4.15.
Then they're all 4
That's right. So the easy way to do it is to say I have 4 green triangles. And the formula for one of those triangles, I can use base times height, can't I? Yeah. It's 1/2, because that's the same thing. 4 times 1/2, the base is 4.15, and the height is 5. Can I do half of the 4?
Half of 4.15.
I can multiply these together. What's 4 times? Yeah, that's 2. 2 times 4.15. Now I'm going to be clever. I'm not going to do 2 times 4.15. I could. I'm going to do 2 times 5, which is 10. So it's 4.15 times 10, so it's 41.5. We're finding area? How many square centimeters? Yep. Did anybody think of this a different way?
How did you get the 4?
Because how many triangles are there? There's 4. Good questions. Those are good questions. Could you take the area of the pentagon and subtract off the area of the triangle? Sure you could. Let's do it that way. That's the harder way, I think. This thing working there. I wasn't sure it was picking up my voice. Okay, the pentagon is 1/2 AP, and the triangle's 1/2 base times height. There's my plan. Those are the formulas I'm going to use. The apothem is 5. The perimeter is 5 sides times 4.15. And then I can subtract off this triangle, which is 1/2. The base is 4.15, and the height is 5. And you know what? I get this. It's the same formula. If you look at it carefully, it's the same formula because I have common factors here that I could factor out. A 1/2, a 5, and a 4.15. If I take those out, just to show you, I get 1/2 times 5 times 4.15, and I'm left with, when I cover those up, greatest common factor, I'm left with 5 minus, and there's a number here, it's 1. That's the 4 that I have over in this part of the problem right here. So it doesn't matter. They're both the same. I did. That's the easy way. The hard way is to take the pentagon minus that triangle. I might have to do a problem like that. It just depends. Might have to do it that way. And then subtract off that triangle, I can. I'm just showing you the greatest common factor here because it's going to come into play later on in other math classes. I'm not expecting you to recognize it all the time. Okay, so what are the formulas we have? First, we have a rectangle. First, let's just do them all. And we all know that. Base times height. These are area formulas. And then we did a parallelogram. Well, guess what that was? Base times height. A triangle is half of a parallelogram. So, a triangle is 1/2 base times height. Then the trapezoid is the one that you might have some troubles with.
I know what it is.
It's 1/2.
B1, B2.
And by the way, it works for a parallelogram. B1 and B2 are the same. I get base times height. It's just averaging the bases for a trapezoid. And then we did a kite. That's another one that's kind of strange. Area is equal to 1/2 the product of the diagonals. What I did on my answer key was I wrote down that this was a kite on the figures. And then I wrote the formula down. So you should, if you got stuck in any of the problems, at least on the first page, figured out what I did to solve the problem. And then we just added, now it's just the regular polygons, right? So it really isn't that much to have to know. It's 1/2 AP, or depending on what you want, 1/2 the apothem times the number of sides times the length of the sides. That's all there is. So it's a short unit. But once I get right triangles in here, it's going to make things more complicated.
Yeah, don't put them in there.
Not this unit, but we will come back and do this again.
Oh,
So now we're going to get out our homework, and you're going to ask me questions on the first page, if there are any, 1 through 8. Those, I believe, are correct online. I'm going to tell you right now that my answer, number 15, is only slightly wrong. It's solved right. And you're going to ask me questions. Are there questions on 1 through 8?
Wait, I think I have a question.
So that's the first one.
I have a question.
See, number 3 and number 7 are kites. 6 might be a problem. I don't know.
I heard that.
Daniel.
I heard it.
7.
Oh, 6. 6.
Oh, we want to do 6 and 7? Well, part of the problem with this one is that you're not recognizing where the base and the height are. So the form, I want to find, oh no, it gives me the area. Area is 31.5. Find B. Now, problem 1 and 2, there may be one of those for an R2, but the rest of the R2s are probably going to be like 6. So I write the formula down. Area equals 1/2 base times height. But what you don't like is that this little triangle here is not sitting on the base. Now it is. So it's 1/2 the base times the height. I got to put my triangle back so I can't read it up backwards. Rotate it. And the height is 9. The base and the height are always connected by the little square. So the height is 9 and the area is 31.5. So since you have a calculator, I would take, well, let's not do it that way. Let's pretend we don't have a calculator. And I can't take half a 9 in my head. I mean, I can. But what I'm going to do is double both sides of the equation. So on the left side, I should get 60. That would be 62. I'm going to get 63, I believe. And I get b times 9, and now I can do this easily. What's b equal to? Why does it equal what? Oh, TJ, you're asking a different question.
What?
You're asking a different question. Okay. Let's look at number 7. Now, we talked about this yesterday. I have it on the board. It should be right, and you should have the work. I don't care that you're using a calculator. That doesn't matter. I want to see how you solve the problem. This is a kite. How do I know? Because this is 17, and this is 17. This is 25, and this is 25. And this length is 20, and this length is 8. And it says find LE. Oh, good, I did do it right. I want this length right there. What's the formula if it's a kite? It's too hard to do if I don't use the kite formula. Area is equal to 1/2 the product of the diagonals. That's why you want your formula sitting in front of you. You look at the formula and say, oh, I want to find the diagonal. And I know the area. Forgot to write that down. The area is 420 square feet, which is 1/2. This diagonal is 20 plus 8, so it's 28 times the other diagonal. Now you can find it. That's 14. If I divide by 14, I'm going to get 30. Did I get that right? Well, I don't know. I don't have my answers on the phone. Were you okay with number 8? 8's a trapezoid, yes. Yes, I know we're going to go to the next one, next page. How about number 10? I have all my work here. It's all posted. I have to fix a problem, though, because I made a mistake. But how about number 10? We had to do number 10 in the other class. Did you guys get 10? Manual question on it? Yeah, ask. It's okay to ask. If you know how to do all these, then you're in the wrong class. This is where you practice. And you know what? You know you're going to have problems similar to this on the test. Again, this triangle is not sitting on the base that I want. So let's see. This is 51. This is 40. This is 24. The area is 924. Can't read that. Find the perimeter. Let's start with the question. Okay, you guys ready? The question is find the perimeter. Well, to find the perimeter is equal to 40 plus 51 plus this side. I don't know what this side is. What would you like to call it? I don't know what it is. Let's call it B. Okay, so that tells me now I need some more information. I need to find out what that side is. Remember that the base and the height are connected by that little square. So the area for the triangle, which is 1/2 base times height, and guess what I have? I have the area for the triangle. That's 924 equals 1/2. I don't have the base. That's what I want. And the height's 24. Okay, do you see what I'm doing? I first started with the perimeter and said, I don't know what B is. Do I have more information to find it? Sure I do. I have the area. By the way, the more problems you do like this, the easier it's going to be. So 9/24, half of 24 is 12, and then we divide by 12. So B ends up being 77, and then you're just going to have to add that up. Then I went around and I looked at 12, and a lot of people didn't have 12 done. Anybody know the answer to 12 without looking at the answers? 12 it's 1/2, and it's the reason why it's hard is because there are no numbers. So I'm going to start with a rectangle. Guess I need a pen. So this is number 12, and I'm going to put a little triangle in there. And it doesn't matter where I put this point. And I'm going to shade my triangle. And it's asking me to compare the area of the triangle to the area of the rectangle, but it does more than that. It says y. So let's find the area of the triangle. Area of the triangle is 1/2 base times height. Here's your height, and there's your base. Is that okay? Now, what's the area of the rectangle? Guess what? It's base times height. This h is the same. So then, if I compare these by looking at the area of the triangle divided by the area of the rectangle, it's equal to 1/2 base times height over base times height. What will happen to the bases and the heights here? They cancel out, and I get 1/2. There may be other ways to show it. That's just the way I see it. Which one?
I'm not tonight.
I can get there, but let's get this one done first. What about 13 and 14? If you have answer only, I'm going to mark it wrong because you haven't done it. There's no way I can do 13 and 14 without doing something. I don't care if you're using a calculator as a tool. You still have to show me how you solved the problem. And some of you are going to take AP Calculus, or you'll take Calculus in college, and they won't give you any credit for work that when you just have answer only. I grade the AP exam. So I know we do not accept anything. Just a plain answer, we will not take it. You have to have the work to support it. Yes. We first should do 15 because my answer to 15 is wrong. The answer is 21. Do I need to do 15? It's a kite. Probably. Well, first off, I could barely see the kite on 15. So I'm going to take it out and make it bigger. There, now I can see it. And I'm going to draw on my diagonals. It's not a pretty picture, but it works. This one's 40. This one's 70. And I just made a silly error. And it says 1 gallon. Now this, you want to talk about reality and real life, this is it. Covers 400 square feet. Go with your parents to Home Depot or the hardware store this weekend and find out how much sealants and paints cost. You don't want to buy more than you have to buy because they're very expensive. It's like $30 or $40 a gallon. So you figure out how many gallons you're going to need. And if you buy a particular color, you have to buy everything you need at once or you'll never match that color again. You have a special blend. So if you want to have a special kind of purple or whatever, and you want it to be the same always, you got to buy all your paint at once. You got to do your calculation right away. I don't know why it's so expensive. It just is. Okay. And then it says, and here's where my mistake was. Okay, we are going to apply the sealant every 6 months. I don't know why I did what I did. I guess I just used to looking at numbers and I pushed them around without thinking about it. And we're going to do this for 3 years, I believe, right? Yes, we're going to do this for 3 years. So really, how many coats are there? I did 6 times 3. I don't know what I was thinking. You're going to do 2 coats a year because it's every 6 months. So it's times 2 times 3. That's why my answer is wrong. Okay.
I think I have the answer.
Because the answer is 21. Mm-hmm. Okay, so let's and I don't like the way I even did it, so I'm going to redo the whole problem anyway. But it'll be here. And anyway, it says 1 gallon covers 400 square feet. So guess what I have to do? I have to find how many square feet there are. And you always have to buy if you have 500 square feet, you're still going to have to buy 2 gallons. Okay, so my area, because it's a kite, is 1/2 the product of the diagonals. Now, I can't see that you would have a shape that's a kite, probably a rectangle, but the problem solving is still the same. And you multiply 40 times 70. Well, half of 40 is 20, so what's the area? How many square feet? 1,400 square feet.
Then don't you multiply it by 2?
Why do you multiply it by 2?
To get the other side of it.
No, that's the whole thing.
Oh, it is? All right.
Yes, that's the whole thing.
All right.
Okay,
That's why.
and how many cans of paint cover this? Once. Well, we have 400 square feet equals 1 gallon. So how many gallons are you going to need? I did it differently in the first hour.
21 gallons.
Why?
Because, you get 1,400 and you divide that by,
So you have 1,400 square feet. Whoops.
so you divide that by 400. Right?
You divide by 400 feet per gallon. No, it doesn't. This is only to do it once.
And that's-
That reduces to 7/2 gallons.
And that's 3 gallons and,
So it's 3.5 gallons.
yeah,
1,400.
And what do you have to do?
Which is,
You have to do it how many times?
6 times.
Times 6. So it's 7/2 times 6.
Alright, so I just thought,
You thought you only had half the kite.
yeah, but how would it be?
That's the whole kite, not just half of it.
It would be half the kind if it was 70 times 20, right?
Right.
Alright, okay.
And you could break it into 4 triangles. Okay. Somebody asked me for another one. 16 or 17?
Oh, let's do 16.
16 are trapezoids. I think I did this right. So we have a hexagon. And then I'm going to put trapezoids on there, maybe. This might be tricky to draw. What are you guys doing?
nothing.
Will you go over number 10 on the homework?
Yes, I'm hoping I'll get there. But if I don't get there today, I'll get there tomorrow.
It's like impossible.
And then I will also do them. Okay. Oh, I didn't want to do that. Okay, I could draw more trapezoids. We know that we can see the picture here. Right? And Hero's formula is just a formula. They call it Hero or Heron. They call him Hero. Okay. What is the area of the entire flower bed? Oh, did I forget? We're just doing the outside. Maybe I forgot the hexagon. Is the hexagon a flower bed? No. The flower bed are the 3 trapezoids. So it's 3 times 1/2 B1 plus B2 times the height. That's my plan. I want the area for those guys. And this is 12. This base is 20. And how big is the height? Well, the height is 7. So it's 3 times 1/2. The sum of the bases is, and I actually wrote it out, 20 plus 12, and the height is 7. So it's 3 times 1/2 of And 20 plus 12 is 32. So it's 3 times 16 times 7, and it turns out to be, 112 times 3, 336.
So the test is Friday, right?
The test is Friday. Okay, so that's the area of my trapezoids. Now, what's my cost going to be? It's $5 per square foot. So it's $5 for 1 square foot. And you're going to multiply it by 336 square feet. So what did I get for that? 1680, did I do that right? What's 5 times 336? I did it in my head, so I could be wrong. Is it wrong?
For what?
336 times 5. So I made an arithmetic mistake. Whoops. See, 3, 30, 18. Oh, 1680. Oh, yeah, I haven't finished it. That's for the square footage, and then you have to add in the flat fee of $100. So the answer is 1780. Okay, now you want to ask me a different question.
Oh, actually, could you just do A and can you confirm this answer with me?
Well, it's 1/2 AP, so it's 1/2 times 24.9 times 24 times how many sides were there? 7. Okay, which one did you say you had problems with on today's lesson? 10? Oh, 10 you have to break into pieces. Well, it doesn't matter how you break it up. You could break it up this way, you could break it up that way. You have to break up the little rectangles, and then you have to add in this hexagon. You just add them up and take your answer by 56, or 85, sorry. So they're just rectangles, but you may have some issues with finding sides, but I'll do it. I'll do it during my prep hour, and then I'll post it, so you'll have the answers, because there are no answers around here. So I'm just doing them. That's all I can do. And on number 9, I would add up, I would count how many triangles I have and just multiply by that. No, this isn't as bad as the one I just did. How about Hero's formula? Did you figure that one out on 17?
Hero's formula, yes. It's easy.
Is it 60 centimeters?
It's 60 square centimeters.
Yes,
But you have to have work.
I have work.
Like that.
Good. Something. Yeah.
I just broke down.
Yeah, that's where I did it. And I showed all my work, so if nothing else, you can copy it, I suppose. I don't want you to copy it, but...
It doesn't make sense because it's way too easy to start out with. You don't need to complicate things.
Well, you know what? You can do it with 1/2 base times height, but Hero's formula works for any
So
triangle.
it works for right angles.
Any triangle.
So it's just foreshadowing it.
Well, if you do math team, you'll need that. Yes, question. Yeah? If it's an n-gon, it's just n. I don't know how many sides.